properties of waves. There are many properties that scientists use to describe waves. They include amplitude, frequency, period, wavelength, speed, and phase. Each of these properties is described in more detail below. Graphing a wave. When drawing a wave or looking at a wave on a graph, we can draw the wave as a snapshot in time. The vertical axis is the amplitude. The vertical axis is the amplitude of the wave, while the horizontal axis can be either distance or time. In this picture, you can see that the highest point on the graph of the wave is called the crest, and the lowest point is called the trough. The line through the center of the wave is the resting position of the medium if there was no wave passing through. We can determine a number of wave properties from the graph. One of them is amplitude. The amplitude of a wave is a measure of the displacement of the wave from its rest position. So remember, this is the rest position. The amplitude is shown on the graph below. Amplitude is generally calculated by looking on a graph of a wave and measuring the height of the wave from the resting point. The amplitude is a measure of the strength or intensity of the wave. For example, when looking at a sound wave, the amplitude will measure the loudness of the sound. The energy of the wave also varies in direct proportion to the amplitude of the wave. So the higher the wave, the greater the amplitude, right? The stronger the wave, the higher the wave, or the louder. Wavelength. The wavelength of a wave is the distance between two corresponding points on back-to-back cycles of a wave. This can be measured between two crests of a wave or two troughs of a wave. The wavelength is usually represented in physics by the Greek letter lambda. This is what lambda looks like. It's pretty cool. Frequency and period. We're really going to talk about the frequency of a wave. The frequency of a wave is the number of times per second that the wave cycles. Frequency is measured in hertz or cycles per second. So frequency is often represented by the lowercase f. The period of a wave is the time between crests. The period is measured in time units such as seconds. The period is usually represented by the uppercase T. The period and frequency are closely related to each other. The period equals 1 over the frequency, and the frequency is equal to 1 over the period. They are reciprocals of each other as shown in the following formulas. So we have T equals 1 divided by F, or period equals 1 divided by frequency. And frequency equals 1 divided by period, or frequency equals 1 divided by time. The speed or velocity of a wave, this is something we'll be doing together as a class, and you'll be actually required to know. So another important property of a wave is the speed of propagation. This is how fast the disturbance of the wave is moving. The speed of mechanical waves depends on the medium that the wave is traveling through. For example, sound will travel at a different speed in water than in air. It will be slower because water is more dense than air. The velocity of a wave is usually represented by the letter V. The velocity can be calculated by multiplying the frequency by the wavelength. So velocity equals frequency times wavelength, or V equals F times lambda. All right, you got it.